Hello students, so here we are with the question 7 part first. So the question 7 is solve the following parts of the linear equation. And the two equations are being provided in part first. What are those? Px plus qy is equals to p minus q. And the second equation is qx minus py is equals to p plus q. And as we have been doing in the earlier questions as well, that these two linear equations can be solved by three algebraic methods. What were those? Elimination, substitution, and cross multiplication method. These equations are not different from the standard equation, but only the difference is that in this constant term also we have the coefficient of x and y being involved, if you can see clearly. And if I see the first equation, that the constant term is the difference of the coefficient of x and y, and also in the second equation as well, it's the negative of the y coefficient and adding it to the coefficient of x. So this is about the constant terms. So I can solve these two linear equations by the elimination method as well. And as I know in the elimination method, I need to ensure that the numerical coefficient of any of the variable, either x and y, should be same in both the equations. But if I focus over the variable y and I see that its coefficient is q and in the second its coefficient is minus p. So in order to make their coefficients same, what I'll be doing, I'll be multiplying both the equation with such a number, or I can say with such a coefficient, that the numerical coefficient comes out to be same for both the equations. Let's see how I'll be doing. Writing the first equation, which is px plus qy is equals to p minus q. And the second equation is qx minus py is equals to p plus q. Now my second step is to make the numerical coefficient value for the variable y to be same in both the equations. So what I'll be doing, I'll be multiplying both the sides of equation first with the coefficient of x, or I can say with the number p, which is constant term. And also I'll be multiplying both the sides of equation second with the coefficient of y, or I can say with the constant value q. Right. So on multiplying, I'll be getting the two equations as p square x plus pqy is equals to p square minus pq. And the second equation will be q square x minus pqy will be equal to pq plus q square. So now adding both the equations, that is first and second, I'll be getting p square x plus q square x. These terms will be cancelling out each other, will be equal to p square minus pq plus pq plus q square. And if I see clearly, here pq will be cancelling out, right? As they are of the opposite sign on the same side. So I'll be getting here p square plus q square into x, as x is common in both the terms, will be equal to p square plus q square. And now taking the term p square plus q square from left hand side to the right hand side, it will be in the denominator. So it will be p square plus q square divided by p square plus q square. As numerator and denominator is same, so these two terms will be cancelling out each other, and the value for the variable x comes out to be equal to 1, which is constant. And as we know, 1, which is an integer value, is a constant value, right? So now in order to get the value for the another variable, that is y, what I'll be doing, I'll be substituting this value of the x in any of the equation, either first or second being provided in the question itself. Let me substitute this value of the x in, say, second equation. So second equation will be q into x, which will be q into 1, which is equal to q itself, minus py is equal to p plus q. And from here, minus py is equal to p, or I can write it as y is equal to p by minus p, which comes out to be equal to minus 1, which is again a constant. So, we have obtained the value for the variable x, which is equal to 1, and also for the variable y, which is equal to minus 1. So, means we have solved these pair of linear equations by using the elimination method. So this was about first part of 7th question. So now coming to the second part of the question 7, the two equations being provided are ax plus by is equal to c, and the second equation is bx plus ay is equal to 1 plus c. So these are the two linear equations being provided in the question. Let me solve this by using the elimination method again. Now suppose I have been focusing over the variable x in this case, and in order to make their coefficients same, so as I can apply the elimination method over these linear equations, what I'll be doing, I'll be multiplying the first equation both sides with the constant b, and the second equation both sides with a constant, say a. The equations from here I'll be getting is abx plus b square y is equals to bc, and the second equation will be abx plus a square y is equals to a plus ac. So these are the two equations being obtained after multiplying with some constants, say b and a, with equations first and 2 respectively. So now what I'll be doing next is I'll be subtracting the second equation from the first equation. What it means is that I'll be altering the sign of the second equation, and after alteration I'll be adding it to the first equation. So here I'll be getting is y, and here in the bracket it will be b square minus a square, and the constant term will be bc minus AC minus A, right? So this will be the constant term. From here, y can be obtained as BC minus A minus AC divided by, taking this term to the right hand side, it will be in the denominator. So here it will be B square minus A square, right? And if we see the terms BC and the term minus AC, we can take C common. So here in the bracket it will be B minus A, then minus A for this term divided by B square minus A square. So this was about the variable y value, right? So what we need to do to find the value for the variable x, I need to substitute this value of the y in any of the equation, either first or second, the choice is being yours. Let me substitute this value of the y in, say, first equation. Substituting it, I'll be getting here a into x, right? Ax plus b into y. Now substitute this value of the y obtained here. So here it will be c b minus a divided by b square minus a square, right, is equals to c. This is the equation being obtained, right? So now what I'll be doing next is I'll be taking the LCM on the left hand side. And taking the LCM of the denominator, it will be b square minus a square. So b square minus a square will be in the denominator. Before substitution, before that is taking the this LCM, let me do some rearrangements so that it will be more easy to find the value for the variable x. Let me take this term to the right hand side. So here it will be c minus B, CB, that is minus B square C, minus ABC, minus, here it will be plus, right, minus AB divided by B square minus A square. So this will be the equation, say first equation. Now I need to solve this equation in order to get the value for the variable x. So what I'll be doing here is I'll be taking the LCM on the right hand side. So now take the LCM, what it will be? Ax is equals to C. Here the common terms will be minus, right? As we have taken this term from the left hand side to the right hand side, so its sign will change. Here it's plus, so here it will be minus. Just remember this. So I'm writing it as C minus B square C minus minus plus ABC minus minus again plus AB divided by B square minus A square. Now taking the LCM, here I'll be getting is, in the denominator it will be B square minus A square, and the numerator it will be C into B square minus A square. So simplifying it, it will be C into B square minus C into A square minus B square C plus ABC plus AB. Right. Now if I have any term cancelling out in the numerator, I'll be cancelling it. So B square C will cancel out. So from here, I'll be getting AX is equals to AB C plus AB minus CA square divided by B square minus A square. Right. Now, see, I can take A common in the numerator. So here it will be AX is equals to A common BC plus B minus AC divided by B square minus A square. So AA will cancel out here and X comes out to be equal to BC plus B minus AC divided by B square minus A square. And if I see the terms BC and minus AC, I can take C common from both the terms. So here it will be C, X is equal to C. On the bracket, it will be B minus A plus B divided by B square minus A square. So means I have obtained the value for the variable y, which is this, and also for the value for the variable x, which is this term, right? So this was about this question. Second part of question 7. I hope this question is clear, as I have used the elimination method in order to get the value for the variable x and for the variable y, which is being cleared, right? Just remember, I have to move to this step after this step, right? So this is about this part. I hope this is clear to all of you. Now coming to the third part of the question 7. So here we have been provided with a pair of the linear equations, right? So the linear equations being provided are x by a minus y by b is equal to 0. This is our first equation. And the second equation is ax plus by is equals to a square plus b square. And suppose I have been solving these two linear equations in order to get the value for the variables x and y by using the elimination method. And as we know, the elimination method says that we need to ensure that the numerical coefficient of any of the one variable is same in both the equations. Suppose I have been targeting over the variable x. And as I see in the first equation, it's 1 by a coefficient. And for the second equation, the coefficient of x is a. So the first case, or I can say the first solution I can give for these linear equation is multiplying both the sides of the first equation with a square. So here I'll be getting is 0 into a square, right, which will be equal to ax minus a square by b y is equals to 0, and the second equation is ax plus by is equals to a square plus b square. So this is the two equations which I'll be obtaining such that the numerical coefficient of the variable x is same in both the cases. This is the first, I can say, option which I can opt for. But instead of doing this, what I'll be doing, I'll be using, that is, I'll be taking an advantage of this minus sign. And as I know, if in one equation, the sign is opposite to that of the another equation of any variable, it's easy to solve, as I can add these two equations easily. Because addition is always simpler, right, than subtraction. So why not to use this minus sign which has been provided in quotient itself? Why not to take the advantage of this sign, right? So I'll be taking the advantage. So now in the elimination method, I won't be focusing over the variable x. I'll be targeting the variable y. That is, I'll make such a mathematical calculation that the coefficient of y is same in both the equations. So say I am multiplying both the sides of the equation first with b square. So here it will be b square into x by a minus y by b is equals to 0 into b square, which is definitely equal to b square by a x, it's square, just keep in mind, okay, don't get confused. It's clear, it's pretty clear over here. B square over a into x minus by is equals to 0, and the second equation is as it is, that is ax plus by is equals to a square plus b square. Now what we can do next is we can add the first equation which we have obtained by doing the mathematical calculation over it, so that its coefficient, numerical coefficient value of the y is same in both the equations. So on adding, I'll be getting here x common, and I'll be adding these two coefficients. Here it will be b square by a plus a. These two will be cancelling out as they are of opposite sign and of the same value, will be equal to 0 plus a square plus b square. So from here, x is equals to a square plus b square divided by b square over a plus a square, right, as I have taken this term from left hand side to the right hand side, so it will be in the denominator. Solving the denominator, that is simplifying it, it will be a square plus b square. Taking the LCM in the denominator, it will be a and a square plus b square, right? So as I can see, these two terms can cancel out. So here, the value of the x comes out to be equal to a, right? So I have obtained the value for the variable x. Now, in order to get the value for the variable y, what I need to do is to substitute this value of the x in any of the equation, either first or second being provided in the question itself. So let me substitute this value of the x in, say, second equation, that is ax plus by is equal to a square plus b square. So substituting here, I'll be getting a into a, that is a square, by placing the value of the a in this, that is a square, plus by is equals to a square plus b square. Or I can write it as by is equals to a square plus b square minus a square, which is equals to b square, because these two terms will cancel out. Right. And from here, y comes up to be equal to b square divided by b, which is definitely equal to b. So now I have obtained the value for the variable x as well as for the variable y, which is a and b respectively. So now what if I substitute these value of the a and b here? So what I'll be getting is, on substituting, that is substitute values of x and y in equation itself, in equations being provided in the question. So a by a will be 1 minus y by b, and the value of the y is b, so b by b will be equal to minus 1, that is 1, as 1 minus 1 comes out to be equal to 0, which is equal to the right hand side of this equation, right? Means left hand side comes out to be equal to that of the right hand side. And what if I substitute the value of the x and y in the second equation? So here it will be ax, that is a into a square, plus by, that is y into y, which comes out to be equal to a square plus b square, which is again equal to right hand side. So I have verified that the values being obtained for the variable x and y is true. So this is about the third part of the question 7. I hope this is clear to all of you. Now coming to the fourth part of the question 7, here the two equations being provided are a minus b into x plus a plus b into y is equal to a square minus 2ab minus b square, and the second equation is a plus b into x plus y is equal to a square plus b square. If I have a look over the second equation, it's clear that the coefficient for the variable x and y haven't been written separately. That is, they are combined and then written in this form. So the first step I'll do here is to write the coefficients of x and y separately. So I'll be getting a plus b into x plus a plus b into y, which is equals to a square plus b square. Right. And now writing the second equation, it is a minus b into x plus a plus b into y, which is equals to a square minus 2ab minus b square. As I have two linear equations in this case, and in order to solve this, let me use the elimination method. And if I focus over the variable y, then the numerical coefficient value of the variable y is same in both of the equations, that is a plus b. So what I'll be doing here is I'll be subtracting the second equation from the first, means altering the sign of the second equation and adding it to the first one. Here I'll get x common, a plus b minus a plus b, which is equals to a square plus b square minus a square plus 2ab and plus b square. Now cancelling out the common terms, here I'll be getting 2bx is equals to 2b square plus 2ab. What if I take common from both of these terms 2b? So in the bracket I'll be left with b plus a. And in the left hand side I have 2bx. So 2b will cancelling out from both the sides. X comes out to be equal to b plus a. So this is the value for the variable x. Now in order to get the value for the variable y, I need to substitute this value of x in any of the equation, either first or second. So let me substitute this value of the x in, say, first equation. That is a minus b into x plus a plus b into y is equal to a square minus 2ab minus b square. So substituting it, I'll be getting here a minus b into a plus b plus a plus b into y, which is equals to a square minus 2ab minus b square. Now if I see the term a into b, a plus b into a minus b, so I can easily apply the identity over here, that is a square minus b square is equal to a into b, a minus b into a plus b. So using that identity here, it will be a square minus b square plus a plus b into y, which is equals to a square minus 2ab minus b square. Now taking these terms, a square minus b square to the right hand side, so there will be a change in their sign. So here it will be a square minus 2ab minus b square minus a square plus b square. Now cancelling the common terms, that is a square minus a square, here I'll be left with minus 2ab. A plus by is equals to minus 2ab. And from here, y comes out to be equal to minus 2ab divided by a plus b. So these are the values for the variable x and y respectively for part 4th of question 7. I hope this is clear to all of you. So now coming to the fifth part of the question 7, here the two equations being provided are 152x minus 378y is equals to minus 74, and the second equation is minus 378x plus 152y is equals to minus 604. So these are the two equations being provided in the question. And as we have done in the earlier questions, what we were doing, we were using the elimination method to solve these questions, right? To solve the pair of linear equations. So what the elimination was saying, that we need to ensure that the numerical value of the coefficient of any of the variable, either x or y, needs to be same in both the equations. So say in this case, we have been focusing over the variable x. So in order to make the variable x coefficient same in both the equations, what I'll be doing is to multiply both the sides of the first equation with 378 and the second equation with 152, which is perfectly right. That is, we can use this method to solve these equations and find the value for the variable x and y. There is nothing wrong in using this method. But if we see, then it don't involve such a big number calculations. Like we need to multiply the number 378 and the number 152 in order to get the answer for these equations. And as these numbers are very large number, and it may arises the chances of getting mistake as well. That is, there is nothing wrong, we can solve this, but for our convenience, for our easiness, why not to use some another method? Why not to solve these equations with some another method? So what that method says, let's see. So the new method in this case is, whenever such cases arises that we have involved such a large number, so instead of using the standard elimination method, or instead of using the cross multiplication method, or I can say substitution method, we can use this method. This is very easy and quickly you can get the answer. So what this method says, first add the two equations being provided. So on adding these two equations, so here it will be minus 226x minus 226y is equals to minus 678. So this is the equation being obtained on adding the two linear equations being provided in the question. And as we know, 226 comes in the table of 678, or I can say 678 is a factor of 226. How? Because 226 into 3 is nothing else but just the number 678. That is, 678 is a factor of 226. So we can take 226 common from both the sides, which will be cancelling out. So here I'll be getting the equation x plus y is equals to 3. This 226 will be cancelling out on both the sides. So this will be the first equation, say. Now how the second equation can be obtained in order to get the value for the variable x and y? Nothing else to be done, just subtract the second equation from the first equation. So as our first equation is 152x minus 378y is equal to minus 74. And the second equation is 378x plus 152y is equal to minus 604. So now in order to subtract the second from the first, I need to alter their sign of the second equation and adding it to the first. So here I'll be getting is 530x minus 530y, which is equals to 530. So now if I see this equation, I can take 530 common from both the sides. So here I'll be getting the equation as x minus y is equals to 1. Let me mark this equation to be the second equation. Now have a look over the first and the second equation. Don't you think this form is very easy as compared to the equations being provided in the question itself? That is, it's very easy to solve these equations which have been formed by adding and by subtracting the two equations being provided. So now what I'll be doing, I'll be using the elimination method to solve the first and the second equation, which means I'll be adding the second equation and the first equation. So here I'll be getting 2x is equals to 4, and from here x comes out to be equal to 2. Now substitute this value of x in any of the equation, either first or second. Let me substitute this in first equation, say. So here it will be y is equals to 3 minus x or 3 minus 2. So from here y comes out to be equal to 1. So means I have obtained the value for the variable x as well as for the y, which is 2 and 1 respectively, in a very easy and quick way. So now the question arises, so I have obtained the value for the variable x and y, but when to use this method and when not to use this method? Is there any specific case when I need to apply this method? Let's see. If I see these equations clearly, replacing the coefficients with some variables, say a and b, so here I can write this equation as ax minus by is equals to c. Here a is equals to 152, b is equals to 378 and c is equals to minus 74. Now writing again the second equation in the form of variable, so here it will be minus bx plus ay is equals to d. And if I see the two equations which have been written in form of the variables, what I observe is the coefficient of x and the coefficient of the y in the two equation is same, and the coefficient of x in the first equation and the coefficient of y in the second equation is same. So what it means is that I can use this method to solve the equations only and only if the value of the coefficient of x and y in the equation is same and the coefficient of x and y in the two equations separately is same. So after adding, what I'll be getting is a minus b into x plus a minus b into y is equals to c. And after subtracting the second equation from the first, I'll be getting the form a plus b into x minus a plus b into y is equals to c minus d. Here it will be c plus d. And if I see these equations, I'll be observing that the coefficient of the x and y in the first equation is same and the coefficient of x and y in the second equation is also same, which means these two equations will be now easier to solve and in a quick way as compared to the standard equations being provided in the question itself. So whenever such cases arises, we can apply this method in order to get our answer in a quick way, right? So this was about the seventh question, fifth part. I hope the seventh question is clear to all of you.